And in your third statement, you will write B equal to C, means B assignment operator C. In your B assignment operator C, means you will assign the value of C into variable B. Okay, so that is the concept of your swapping. So, as per I had told, the sorting algorithm is in place of comparison based algorithm in which the list is divided into two parts. Means in your selection sort algorithm, your list will divide it into two parts. The sorted part at the left hand and the unsorted part at your right hand. As per I had told, when you are applying the selection sort in your unsorted array, in your selection sort algorithm, your list is divided into two parts, your left part and your right part. Okay. And at your left and the means your sorted part at your left hand and your unsorted part at your right hand. Initially, the sorted part is empty and the unsorted part is the entire list. Means in your selection sort algorithm, your array, your list is divided into two parts. Your left list and your right list. Okay. In your left list means your elements will in sorted manner, and in your right list your all elements will in your unsorted manner. Okay. At your initial position, your left hand side list will be empty, and in your right side array, your all list will be displayed. Okay. I had told the smallest element is selected from the unsorted array. First of all, you will select the smallest element from the unsorted array, which I have taken, and swapped with the leftmost element. And the element become a part of your sorted array. And this process continue moving unsorted array boundary by one element to the right. This is your sorting algorithm. Again, I am explaining about the sorting selection sort algorithm. In your selection sort algorithm, your list will be divided into two sublists. Your first is your left hand side array, and second is your right hand side your array. Okay. Your left hand side your array, the sorted elements will exist, and in your right hand side your array, your unsorted elements will be exist. At your initial position, your left hand side list will empty, and your right hand side list will contain the all entire list. Okay. And the smallest element is selected from the unsorted array, and swapped with the leftmost element, and the element become a part of the sorted array. This process continue moving unsorted array boundary by one element to the right. Okay, so that is your selection sort algorithm. And now I am taking the example of your selection sort algorithm. I hope you will better understand about through your example of your selection sort. First of all, I am taking the array of your elements, and your all elements are not in your sorting fashion. Means at your initial position, your all elements are in your unsorted fashion. Okay. You know what is your array? You know, array is the collection of your similar type of your items, similar type of your elements. Like suppose I want to take the 100 student marks. So mean obviously your all students will having the marks like your 10, 20, 30, 40, 50, 60, 70, 80, etc., etc. Okay, that is your array. Okay, and when I want to store the 100 student marks on your array, so first of all, I will read the marks of 100 student from the user side. In the same manner, I am taking a array of your 10 or 12 elements, and for at your initial position, your all elements will store one by one. Means your all elements I will take from your user side. Okay. First of all, I am taking a unsorted array which contain the items 14, 33, 27, 10, 35, 19, 42, and your 44. This is the array of elements, like as per I had told me that this is my unsorted array. Okay. For the first position in your sorted list, the whole list is scanned sequentially. The whole list is scanned sequentially means first of all I will take the all elements from your user side, and the first position where 14 is your sorted presently. You can see in my PPT your first element, that is your 14. Your first element that is your 14 is stored presently. Okay, and we search the whole list and find that the 10 is the lowest value. You can see in my shared PPT, 10 is the lowest value of this array, and I had presented the lowest value, that is your 10, in your red color. Okay, so that time your array will be 14, 33, 27, 10, 35, 19, 42, and your 44. Okay, and 10 is your lowest value as per I had marked at your red color. Okay, after that, you know your 14 is greater than from your 10, so we replace your 14 with 10. After one iteration, 10, which happen to be the minimum value in the list, appear in the first position of the sorted list. You know, 10 is the lowest value of your array which I have taken. So your 10 should be the first value of your array because 10 is the lowest value. Okay. But in this list, when we have to compare from 14 to 10, so you know your 14 is greater than from your 10. Okay. So at this time, your swapping is required. Means at this time, your need of your swapping because your 10, 14 is your greater than from your 10, and as per the rule of your sorting, 10 should be the first element of your array. Okay. So when you will apply the swapping, as per I had told, you can take the third variable and you can apply the swapping without your third variable. So suppose you are taking a third variable for the swapping. At this time, your two values are 10 and 14. Okay. Means you will, when you will implement the concept of your swapping, so you will take the two variable and your first variable will take the value of a value is 10 and your second variable will take the value that is your 14 to the b variable, to the b variable. Okay. So first of all, you will take, as per I had told, you will take the third variable, that is your c. So first of all, if your 10 is the value of your a and 14 is the value of your b, so 10 will assign into your variable a, and after that, your b variable, that is your 40, will be assigned into your a, and in your third statement, that is your b equal to temp variable, so your temp variable value will assign into your b variable. Means after swapping, your 10 value, which is the lowest value of your array, will take the position of your 14, and your 14 will take the position of your 10. Means that time your array look like this, where your 10 is the first element of your array, 10, 33, 27, 14, 35, 19, 42, and your 44. Okay. And after that, for the second position, where 33 is residing, so we start scanning the rest of the list in your linear manner. Okay. And that time your array will look like this: 10, 33, 27, 14, 35, 19, 42, and your 44. And we find that 14 is the second lowest value in your 33, 27, 14, 35, 19, 42, and 44. When we compare the all values, which are 33, 27, 14, 35, 19, 42, and 44, 14 is the lowest value. And I had marked the lowest value, that is your at your so after two iteration, the list value are positioned at the beginning in your sorted manner. Obviously, your 14 will compare from 30. You know your 33 is greater than 14. That time is required. I had told the many times concept of your sorting, of your swapping. I hope that time there is no need of your swapping concept. So that time your 14 will take the place of your 33 after swapping, and your 33 will take the place of your 14 after swapping. Okay. And your 14 will take the place of your 33, and your 33 will take the place of your 14. And your array look like this: 10, 14, 27, 33, 35, 19, 42, and 44. You can see, as per I had told, your sorted elements in your left hand side array and your all unsorted elements in your right hand side array. Okay, so you can see I had marked the sorted elements in your green color. Okay, so you can see your 10 and 14 are sorted, and these all elements are placed in your left hand side array, and your all unsorted elements which are placed in your right hand side array. Okay, so that time your array look like this: 10, 14, 27, 33, 35, 19, 42, and your 44. Okay, and the your same process is applied to the rest of the items in your array. And now your 10 or 14 are already sorted and which are placed in your left hand side array, and as per I had told, your unsorted elements which are placed in your right hand side array. In your right hand side your array, you can see your 19 is the lowest value from your right hand side your array. And I had also marked the lowest value from your right hand side array, that is your 19, in your red color. Your 19 will compare from your 27. When your 19 will compare from your 27, so your 19 is less than from your 27, and in your right hand side summary, your 27 at your first position and your 19 as your third and fourth position. So as per your sorting, your 19 value should place uh, on your 27 position, and on your first position, and your 27 should be placed in your 19 element position. So that time your swapping is required, and after the swapping, your 19 value will take the place of your 27 value, which are placed in your first position, and your 27 will take the place of value of 19 element. Okay. That time your array look like 10, 14, 19, 33, 35, 27, 42, and 44. And as per I had told, when you have to compare the 27 from your 19, and after the swapping, your 19 will take the value of your 27, and your 27 will take the value of 19. That time your array look like 10, 14, 19, 33, 35, 27, 42, and your 44. Okay, and in this array you can see your 10, 14, and your 19 are in your sorted fashion, and your 33, 35, 27, 42, 44 are in your unsorted fashion. Okay. Your all sorted elements, which are your 10, 14, 19, I had marked in your green color. Okay. And that time your array look like this: 10, 14, 19, 33, 35, 27, 42, and your 44. Okay. And after that, in your unsorted array, which are your 33, 35, 27, 42, and 44, 27 is the lowest value, and 33 is the greatest from your 27, which are placed at your first position in your unsorted array. After swapping, after swapping, your 27 will take the place of your 33, and 33 will take the place of your 27. Okay. And that time your array look like 10, 14, 19, 27, 35, 33, 42, and your 44. Okay. And after that, from your unsorted array, in which your element are placed 35, 33, 42, and your 44, 33 is the lowest value from your unsorted array, and your 33 will compare from your 35. Okay. And 30, your 33 is less than from your 35. Okay. That time your swapping is required, and your 33, after the swapping, your 33 will take the value of your 35, and 35 will take the place of your 33. Okay. And your array look like this: 10, 40, 19, 27, 33, 35, 42, and your 44. You can see your all green marks, green colored numbers are placed in your sorted fashion, and your white color marked all elements are placed in your unsorted fashion. As per I had told, in your succession sort algorithm, in your left hand side, all elements are sorted, and in your right hand side array, your all elements are not in your sorting fashion, as per I had told. Okay. So in your right hand side array, 35, 42, and your 44, all are in your sorting fashion, because your 35 is less than from your 42, and your 42 is less than from your 44. To mean that time your swapping is no required. So your array look like 10, 14, 19, 27, 33, 35, 42, and your 44. Okay. Means after swapping, where where your swapping is required, after swapping your array look like in your sorting fashion, like your 10, 14, 19, 27, 33, 35, 42 in your 44. The main key concept in your selection sort algorithm, where your array in your unsorted fashion, so your array is divided into your two subarray, your left hand side subarray and your right hand side subarray. In your left hand side your subarray, all elements are in your sorting fashion, and in your right hand side your subarray, all elements are in your unsorted fashion. And at your initial position, your right hand side subarray will be empty, and your left hand side subarray, your all elements existing in your array. That is the key concept of your selection sort algorithm. And now I am taking the algorithm of your selection sort. You know, your algorithm, your algorithm means step by step instructions for achieve the object, step by step instruction for achieve the goal. That is your algorithm. There is no any foundation. You first of all you will write this instruction. After that you will write this instruction. After that you will write this instruction. There is no any foundation. Only simple concept of your algorithm, you will write the instruction only step by step for achieve the goal according to your purpose. That is your algorithm. After taking the example of your selection sort, I am writing the algorithm of your selection sort. You know, algorithm is the first step for solving the any problem. When you are writing the program for solve the any problem, when you are making a software for any problem, first of all you will write the algorithm. But nowadays new trend is that student will directly write a program for solve the problem. That is not a right way. As per your right way, first of all student should write the algorithm, and after write the algorithm, student will make the program. Without write the algorithm, if your student will make the program, so obviously your student will face the problem. Okay, that's why, as per my suggestion, when you are writing the any program, so before write the program, you should first of all you should write the algorithm. If you have to write the algorithm, that means your all concept are clear about your program. And before and without writing the algorithm, if you are making the program, so obviously you will face the problem. Okay, so here I am describing the algorithm of your selection sort. You know, your first step of every algorithm start. Okay, and here in your first step, set min means minimum to location 0, and in your second step you will find the minimum element in the list. As per I have taken the example in which your array will divided into your subarray, your left hand side subarray and your right hand side subarray. And in your left hand side subarray, your all elements should be in your sorting fashion, and in your right side summary, your all elements are not in your sorting fashion. Okay, and first of all, you will find the minimum element in your list. That is your second step of your algorithm. And in your third step, swap the value at location min means minimum. Okay, so means you will apply the swapping concept whenever required. Okay, and swapping is required only in which case where your first value is greater than from your adjacent value. If your first value is greater than from your adjacent value, and you want to sort it them, that time your swapping is required. And I had already told, in your swapping, your first variable's value will take the place of your second variable, and your second variable's value will take the place of your first variable. That is your swapping. And after that, increment mean to point to the next element. Okay, and you will repeat until list is your sorted, that this is your last step. Means you will repeat this concept until your list is your sorted. Okay, this is the algorithm of your sorting, right? And after that, implementation of your selection sort. So when you will implement the selection sort, first of all, you will take the list. List means your array of your items, your array of your elements. You can take the array as per your size. Suppose you want to take the array of your six element, you can take. Okay, so means your list, first of all, you will take the list, and your list is the array of your items. And second, n is the variable, n is the size of your list. Means if you are taking the 10 elements in your array, so 10 is the size of your array. If you are taking the 12 elements in your array, so your 12 is the size of your array. Okay, when you will implement the selection sort algorithm, you will take the array of your items, and you will take the size of your array. Okay, as per I had mentioned, list array of your items, and n is the size of your list. Okay, and you will applying the loop, and your loop will start from your 1 to n minus 1. Your n is the size of your list. Suppose your size is your 10. Your size is your 10. That time your loop will start from 1 to 9. As per I had wrote, your loop is start from your 1 to n minus 1, and your n equal to 10. Mean the size of your list is your 10. Okay, so if your size is your 10, that means your loop will start from your 1 to n minus 1. N2 minus 1 means 10 minus 1, that is your 9. Means your loop will start from your 1 to 9. Okay, and I had also mentioned the all comments. Set current element as your minimum means you will set the minimum element as per I had told in your sorting algorithm. You will find the minimum element from your list. Okay. When you will implement this algorithm, you will find the minimum element from your list, and when you will implement, you will write min assignment operator I. Okay. And check the element to be minimum. Okay. And your loop start from your j assignment of I plus 1 to n, and you will compare your item is less than from your minimum position. Okay, means you will compare and swap the minimum element with your current element. Obviously, as per I had told, if your first item of your array is greater than from your lowest item of your array, that time your swapping is required. If your first item is less than from your lowest item of your array, so that time your swapping is no required. Okay, so the main key concept in your sorting algorithm is your swapping, and you know your swapping is required only in which case where your first element is greater than from your adjacent element as per your sorting fashion. That time your swapping is required. Okay. And if index min is not equal to I, then your swap list min and your list I and your end procedure. Obviously, if you apply the condition, so if your condition will start, so always your condition should be finished. And if you will start the loop, obviously your loop should be finished. And if your procedure will start, so your procedure will finish. Okay. And after the pseudocode, after the algorithm of your selection sort, now I am talking about the advantage of your selection sort algorithm. Okay. There are so many advantage of your selection sort algorithm. The main advantage of your selection sort algorithm, this sorting algorithm is suitable for the small list. If you are taking the small size of your if you are taking the small size of array, so that time your selection sort algorithm is best. And if you are taking the large size of your array, so your selection sort is not suitable for this task, that is your sorting. Your first main advantage of selection sort is that it performed well on a small list. If you are having a small list, if you are having a small array of your unsorted items and you want to sort sort them, you should follow always selection sort algorithm, because your selection sort algorithm is suitable for your small size of your list, because it is in a place of your sorting algorithm. No additional temporary storage is required beyond what is needed to hold the original list. And the another advantage of this algorithm, its performance is easily influenced by the initial ordering of the item before the sorting process. These are the all advantage of your sorting algorithm. Main advantage of your of your selection sort algorithm, this algorithm is suitable for the small size of your list. If you are taking the big size of your array and you want to sort them, so for the long size of your array, this selection sort algorithm is not suitable, and temporary no additional temporary storage is required, and its performance is easily influenced by the initial ordering of the item before the sorting process. And the disadvantage of your selection sort algorithm, the main disadvantage of your selection sort is to poor efficiency when dealing with the hug list of items. As per I had told, if you are taking the large number size of your array, the efficiency of your selection sort algorithm is not good. The efficiency of your sorting selection sort algorithm is slow when you are taking the large number size of your array. This is your primary disadvantage of your selection sort algorithm. And the selection sort require n squared number of your steps for sorting n elements. And the your quick sort is the one of the algorithm of your sorting, one of the technique of your sorting. So your quick sort is much more efficient than your selection sort. Okay, so means your main disadvantage of your selection sort algorithm, this selection sort algorithm will show the lowest performance when you are taking the large number size of your array. Okay, and after study this lecture, student should able about the what is your selection sort, what is your array, and also students should able to write the algorithm of your selection sort, and how to implement this selection sort algorithm. You know, when you want to implement the algorithm, so you can use the any language. There is no foundation ki only this algorithm will implement only in this language, only in this language. If you want to implement the algorithm in your C language, C++ language, Java, PHP, Python, there is no any foundation. You can implement the algorithm in any other language. Okay. I am taking the some questions, and student will solve these all questions After studying this lecture, here I am presenting the some MCQ questions regarding to this your selection sort algorithm. What is in place sorting algorithm? Maybe it needs one or log n memory to create auxiliary locations. Input is already sorted and in place. It require additional storage. It require additional space. Your auxiliary memory is required for storing the data temporary. Or here in your sorting algorithm, you will take the data and you will store the temporary. Auxiliary memory is required for storing the data temporary. And another question is that in the following scenario, when will we use the selection sort? As per the question, the input is already sorted. The large file has to be sorted. Large value need to be sorted with small key. Small value need to be sorted with large key. Your selection is based on your key. Hence, that's why a file with the large value and a small key can be efficiently sorted with the selection sort. So obviously, your large value need to be sorted with the small keys. Okay. And next question is that what is the advantage of your selection sort over other sorting technique? It required no additional storage space. It is scalable. It works best for the input which are already sorted. It is faster than any other sorting technique. So your selection sort is in place of your sorting algorithm, and it does not require the additional storage as per I had told. And any other question? What is the average case complexity of the selection sort? The average case complexity of a selection sort is that n square. In the average case, if the input is partially sorted, the selection sort behave as the your if the entire array is not sorted. The selection sort is a incentive to input. So, the average case complexity of your selection sort is that n square. And what is the disadvantage of your selection sort? It requires auxiliary memory. It is not scalable. It cannot be. It can be used for a small key. It takes linear time to sort the elements. As the input side increase, the performance of selection sort decrease. Obviously, if as per I had told, if you are taking the large number size of your array, so your selection sort will performance will slow. If you will take the lowest number size of size array, so your selection sort performance will increase. It means as the input size increase, the performance of selection sort decrease. And suppose your array is your in your array contain the some items like your 3, 4, 5, 2, and 1. The number of iterations in your bubble sort and selection sort respective. But here I am talking about your selection sort. The number of iterations are required. As per I had told, when I was implement this algorithm, I had told your loop start from your 1 to n minus 1. Means if you are taking the 10 number size of your array, so your only 9 iterations are required. Means n minus 1. Your loop will start from your 1 to n minus 1. Means your loop will run at 9 times. Okay. So in this given question, your array size is your 6, 3, 4, 5, 2, and 1. Okay. Means the size of your array is 5. So that time your iterations are required. That is your 4. Okay. Since the input array is not sorted, bubble sort takes 5 iterations and succession sort take 4 n minus 1 iterations as per I had told. What is the best case complexity of your section sort? N log n, log n square. Obviously, the best case complexity of section sort is that your n square, n minus 1 plus n minus 2 plus n minus 3 plus dot 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 plus 1. That is your series. So when you will execute this series, your answer will be n minus 1 upon 2, and that is your equal to n square. The best case complexity of your section sort is your n square. After studying this lecture, student will able to what is your sorting array, where is section sort algorithm is required. If you are taking the large number size of your array, so that time your section sort algorithm is suitable or not, and about the algorithm of your selection sort. Means after study this lecture, student will understand about the concept of your selection sort algorithm, where a selection sort is required, sorting your array. In this lecture, I had discussed about your section sort algorithm of your sorting. There are so many algorithms of your sorting, like your selection sort, merge sort, insertion sort, bubble sort, merge sort, radix sort, quick sort. There are so many algorithms, there are so many techniques for arranging the items in your sorted fashion. Okay. And here I had discussed about only your section sort algorithm. In your my next coming lecture, I will discuss about other algorithms of your sorting. Thank you.